Greetings, science family. Today we're going to be looking at Periodic Trends Worksheet 1, where we start using the periodic table trends in order to predict some different properties of elements that we're comparing. So if you look, round one, the battle of the elements, we're going to be comparing sodium versus magnesium. So sodium is right here and magnesium is right here. So based off their location on the periodic table, we can start to determine different properties about them. So question number one says, who has the larger atomic radius? Well, if you remember, when you go from left to right on the periodic table, atomic radius gets smaller and smaller. So because sodium is to the left of magnesium, sodium is going to be the element that's going to have a larger atomic radius. We know that trend. As you go left to right, radius gets smaller. How about more valence electrons? Well, if you remember the valence electron trend, it's 1, 2, 3, 4, 5, 6, 7, and 8. So because magnesium's in column group 2, magnesium is going to have more valence electrons because sodium only has 1. Now, which is going to form a larger positive charge? Well, if you remember, there is a trend as well on the periodic table. Group 1 forms +1 charge, group 2 forms +2, group 3 forms +3. We pretty much skip group 4 because it could be a plus or minus 4, though that doesn't happen very often. And then group 5 is a -3, group 6 is a -2, and group 7 is a -1, and group 18 there is going to be 0 because it has no charge. So which one forms a larger positive charge? Since magnesium is in group 2, magnesium is going to win because it forms a +2 charge as opposed to sodium with a +1. Now, who is more electronegative? If you remember the trend for electronegativity increases as you go from left to right. In fact, remember, fluorine is the most electronegative element on the periodic table. So the closer you get to that, the more electronegative you are. So since magnesium is closer to fluorine, magnesium is going to be more electronegative. Who has the larger ionization energy? That trend, if you remember, the smaller the element, right, the harder it is to pull an electron off of it. So as you go from left to right across the periodic table, because elements are getting smaller, it's going to be harder to pull electrons off of it. So that means it's going to require more energy. So since magnesium is smaller in size, it's going to take more ionization energy to pull an electron off of it because it's holding onto its electrons even tighter. Okay, how about the very last question? The very last question is, which metal is more reactive? If you remember, for reactivity of metals, the larger the atom, the more reactive it becomes. So as you go from right to left, the reactivity increases. So since sodium is to the left of magnesium, sodium is going to be more reactive than magnesium. All right, so what we did is we looked at the periodic table, tried to take its trends in order to help us figure out some different properties of these metals. Let's take a look at round 2 as I move this up. And let's look at 2 non-metals that happen to be in the same group or same family. Fluorine and chlorine are both halogens. So fluorine is above chlorine. Because of that, that's going to make a difference in some of their properties. So first of all, who has a smaller atomic radius? Well, remember, as we go down the periodic table, the size of the radius gets bigger and bigger because you're adding an energy level. So fluorine, because it's above chlorine, would have a smaller atomic radius because it has 1 less energy level than chlorine. Who has less valence electrons? Well, remember the trend. 1, 2, 3, 4, 5, 6, 7, or 8. So who has less valence electrons? That's a trick question. They both have 7, so they are equal to each other. Who forms a larger negative charge? Well, if you remember from your trends, right, the nonmetals, group 5 makes a -3 charge, group 16 makes a -2 charge. Sorry, having trouble writing there. Group 17 makes a -1 charge. So they're equal again because they both form a -1 charge. Now, who is more electronegative? If you were listening to the example from earlier, right? Fluorine is the most electronegative element. In fact, when you go up the periodic table and to the right, electronegativity increases. So since fluorine is above chlorine, fluorine is considered more electronegative. Which nonmetal is more reactive? If you remember, reactivity is the same as electronegativity. As you go up and to the right, nonmetals get smaller. And since they get smaller, they get more reactive. So fluorine definitely is the more reactive. So in round 2, it looks like fluorine took the win here over most other people. Sounds good. All right, let's cruise on up to the next part, decision. All right, it has some questions for us. Let me make that a little bit bigger so we can write. Number 1 says, what are the elements called that fall on the staircase of the periodic table? That's a good question. Remember, the staircase on the periodic table is this area right around here, right? It divides the metals and nonmetals. What do we call that group? We either call them the semimetals because they're in between the metals and nonmetals, or remember, we call them the metalloids. And the reason we call them the metalloids again is because they have properties of both metals and nonmetals. Sorry for my handwriting on the screen, but you get the idea. Let's go to question number 2. Sodium belongs to which family on the periodic table? Let's scroll down. Sodium is right here. It's in the very first family, the very first group on the periodic table. What is the name of the family in group 1? It's going to be the alkali metals. Now you should think back. There's a bunch of different family names you were asked to know. Make sure you know alkali metals, alkaline earth metals, transition metals, noble gases, and halogens. Speaking of that, the next question is, what family does magnesium belong to? Magnesium is in group 2. In group 2, on the periodic table, all have similar properties, and they're called the alkaline earth metals. So that is a good piece of information to know. The reason we like to call families by name is because they usually act pretty similar with their chemical reactivity and have similar properties. All right, let's look at the next question. How many valence electrons do halogens have? Well, halogens are group 17. Group 17 is fluorine, chlorine, bromine, iodine, etc. So if they are group 17, they have 7 valence electrons. If you recall, remember the trend. Group 17 has 7 valence electrons. You just drop the teen. All right. And last but not least, how are the elements from round 1 different from round 2? Okay, well, if you look at round 1 was sodium and magnesium, and round 2 was fluorine and chlorine. First of all, the way they're different, right, is metal versus non-metal. So group 1 are metals, and group 2 are nonmetals. What's another difference between them? Metals always form a cation versus nonmetals always form anions. What's another difference between them? Well, you could look at the difference between metals and nonmetals. The idea that group 1, they should be shiny and full of luster. And then the group 2 elements, since they're nonmetals in that, they actually are gases. They don't even have a dull look to them. They're pretty much clear. We really wouldn't see them, though chlorine does have a green tint to it. But in the end, they're very different. You could do plenty more. You could say metals in group 1, in the round 1 group, they were in 2 different groups, where the round 2, fluorine and chlorine, were in the same group or family. So there's a lot of differences between them. But in the end, I hope this helped out and allowed you to better understand how we can use the periodic table to find some different trends. All right, thanks for sticking with us, ChemFam. Be well. Heading to the back page, we are now going to compare magnesium atom to the magnesium ion. Remember, the magnesium atom has no charge, and the magnesium ion has 2 charges. So first is, how many valence electrons does the magnesium atom have? Well, magnesium is in group 2. So therefore, if we look at the valence electron trend, magnesium atom is going to have 2 valence electrons because it's in group 2. Next question is, what is the symbol of the magnesium atom? Well, magnesium is just Mg, right? Does the magnesium atom gain or lose electrons to become an ion? Remember, if magnesium has 2 valence electrons, it either wants to lose those 2 electrons to empty its energy level, or it wants to gain 6 to get to 8. Remember, everything wants to get a full energy level, so it wants to get to 8. Or if it goes down to 0, it unlocks the previous energy level. So which is quicker, losing 2 or gaining 6? It's going to be lose 2 electrons. That's going to be a lot quicker. Is the magnesium atom a cation or anion? Good question. If you lose electrons, you now have more protons than electrons. So therefore, if you lost 2 electrons, you are going to have a positive charge because you'll have more protons. So you'll be a cation. What is the symbol for the magnesium ion? It's going to be Mg with a 2+, saying that now magnesium has a 2+ charge because it lost those 2 electrons. Looking at the next section, we are going to look at oxygen and compare it to its ion form. So first of all, how many valence electrons does oxygen have? Well, the trend for valence is 1, 2, 3, 4, 5, 6. So since oxygen is in group 16, it has 6 valence electrons. What's the symbol for the oxygen atom? Simple, it's just O, since it's neutral, it has no charge. Does the oxygen atom gain or lose electrons to become an ion? Well, it has 6 valence electrons, so it could either lose 6 and go down to 0, or simply gain 2. Gaining 2 is a lot quicker and easier, so oxygen is going to gain 2 electrons. If it does that, if it gains electrons, it now has more electrons than protons. So it'll have a negative charge and become an anion because you have more electrons than protons. What would be the symbol for the oxygen ion? Well, it's always going to be O for oxygen, but since it gained 2 electrons, it now has a 2- charge. So it's O2-. Tackling the last section, we are going to look at aluminum, Al. All right, the first question is, how many valence electrons does aluminum have? Well, the trend is 1, 2, 3. So aluminum's group 13, so it has 3 valence electrons. What is the symbol for the aluminum atom? Well, it's just Al, since there's no charge. It's just its symbol. Does the aluminum atom gain or lose electrons to become an ion? Well, if it has 3 valence electrons, it could either lose 3 to go down to 0 or gain 5 to go to 8. Remember, you either want to go to 0 or 8 to be stable. Losing 3 is quicker than gaining 5. So that means aluminum will lose 3. Now, if you lose electrons, that means you're going to have more protons, which means you're going to have a positive charge. So that means aluminum would become a cation. If aluminum is a cation, what's the symbol for it? Well, the aluminum ion would be aluminum, but since it lost 3 electrons, it now has 3 more protons, so it would have a positive 3 charge overall. Right, so hopefully that showed you that knowing the trends of the valence electrons, and don't forget there is a trend for charge too. For the metals, it's +1, +2, +3, and then for the non-metals, if you skip carbon, it's going to be -3, -2, -1, and then noble gases are 0. So if you remember the trends, it does help you out quite a bit, but understanding the trend is super important. Understand why when you lose electrons, you become positively charged, and when you gain electrons, you become negatively charged. Then you're empowered and you don't have to memorize any trends. You can just use rational thought to get your answer. All right, nice job, science fam. Keep up the good work.